When you drop a ball, it falls down. You push something, it moves. You see that, right? These are causal relationships. One event, you dropping the ball, causes another event, the ball falling. This seems obvious, common sense. And for most of our everyday experience, causality seems to be instantaneous. You push, it moves right away. But Einstein came along and said something radical. He said that causality has a speed limit, and that speed limit is the speed of light. Now, why would he say that? Well, it comes from something very deep about the nature of space-time itself. You see, we don't live in space and time as separate things. That's Newtonian thinking. We live in space-time, one unified thing. Events happen at locations in space, sure, but they also happen at moments in time. An event is a point in space-time. It has both a position and a time. Let me give you a concrete example. Suppose I'm sitting here and I do something. Let's say I clap my hands. That's an event. It happens at a particular location in space and a particular moment in time. Now the question is, what other events in the universe could my clap possibly have caused? Here's where it gets interesting. My clap cannot instantly cause something to happen on the other side of the galaxy. And do you know why? Because information about my clap would have to travel across that distance, and information can't travel faster than light. It just can't. This isn't a limitation of our current technology. This is a fundamental law of physics. And it's not some arbitrary law that Einstein just made up. It follows from something deeper, from the principle of relativity itself. Think about it this way. The laws of physics are the same in every reference frame. That's what relativity says. And one of the laws of physics, which comes from Maxwell's equations about electromagnetism, is that light travels at a certain speed. But here's the kicker, that speed is the same in every reference frame. A light ray travels at 300,000 kilometers per second in my frame, and it also travels at 300,000 kilometers per second in your frame, even if you're moving relative to me. That seems impossible at first. Velocities should add. If you're moving towards something, it should seem faster, but light doesn't work that way. Now, Einstein added one crucial assumption on top of this. He said the speed of light is the maximum speed for any physical process. And from that, everything follows. Because if information can't travel faster than light, then causality can't operate faster than light. And if causality can't operate faster than light, then the universe has a built-in structure that tells us which events can influence which other events. This is where the light cone comes in, and this is really the heart of what I want to explain to you. Imagine an event. Let's call it Event P, right here where I am, right now. Now, which other events in spacetime can be influenced by Event P? Well, any event that I could send a light signal to. If I send out a light signal in all directions from Event P, where can that light signal possibly go? It can reach any point within a cone-shaped region expanding outward at the speed of light. That region is called the future light cone of Event P. Now, why is it called a cone? Because we live in 3 dimensions of space, right? So if I send out light in all directions, it forms an expanding sphere. And if I plot this on a space-time diagram, with time going up and space going sideways, that expanding sphere at different times traces out the surface of a cone. The vertex of the cone is at event P, and the cone opens upward into the future. Everything inside that future light cone is an event that could potentially be caused by P. Everything outside the future light cone cannot be caused by P. Why? Because to influence those events, information would have to travel faster than light, and that's impossible. Now here's something beautiful. The situation is symmetric in the past. There's also a past light cone for any event P. The past light cone consists of all the events in the past from which a light signal could have reached me right here, right now. And any event outside that past light cone could not have caused the current event P. It's too far away in space and too close in time. The information wouldn't have had time to reach me. So at any given moment, at any given event, the universe is divided into 3 regions. First, there's the future light cone, events I could potentially influence. Second, there's the past light cone, events that could have influenced me. And third, there's everything else, events that are causally disconnected from me. We call those events elsewhere. And here's something profound. Events that are elsewhere from me cannot influence me, and I cannot influence them. There is no possible causal connection. This is completely different from Newtonian mechanics, where you could imagine that anything could influence anything else instantly. In Newton's picture, the universe was like a giant machine where all the gears were connected instantly. If you moved something here, everything across the galaxy would instantly be affected. But relativity says no. There is no instantaneous action at a distance. Everything travels at speeds less than or equal to the speed of light. Now, let me tell you why this is so fundamental. This isn't just a mathematical curiosity. This structure, the light cone structure, this is what determines causality in the universe. Einstein understood this deeply. He said that relativity isn't really a theory about objects moving. It's a theory about causality. It's a theory about what can influence what. And here's something else that's really important. This light cone structure doesn't depend on your reference frame. If you're moving relative to me, your light cones are oriented the same way as mine. They all tip at that 45-degree angle in a space-time diagram because everyone measures light traveling at the same speed. This is why all observers, no matter how they're moving, will agree on the causal structure of space-time. They might disagree on which events are simultaneous. That's relativity of simultaneity. But they will agree on which events are causally connected. Now, let's think about what this means more carefully. Suppose I want to send a message to someone on the other side of the galaxy. How long does it have to take? Well, the fastest it could possibly take is the time it takes light to travel that distance. If the galaxy is 100,000 light years away, then the message has to take at least 100,000 years. There's no way around it. You can't beat the speed of light because causality can't travel faster than light. And here's something that troubled physicists for a long time. What if you could go faster than light? What would happen? Well, something very strange. If you could go faster than light, you could actually travel backwards in time. Let me show you why that's true. Imagine in one reference frame, event A happens before event B, but imagine I'm moving really fast in another direction. In my reference frame, I might measure event B happening before event A. So if something could go faster than light from A to B, in some reference frames it would look like it's going backwards in time. And if effects could travel backwards in time, you get all sorts of paradoxes. You could affect your own past. You could prevent yourself from being born. This violates causality in the deepest sense. So the prohibition on faster-than-light travel isn't just a speed limit. It's protecting the entire logical structure of the universe. It's protecting causality itself. That's how fundamental it is. Let me give you another way to think about this. The speed of light isn't really about light. Light just happens to be something that travels at that speed. But you know what else travels at that speed? Gravitational waves, radio waves. Anything that's massless travels at the speed of light, and anything that has mass travels slower than light. An electron, a proton, you and me, we all travel slower than light. And there's a beautiful symmetry here. The speed of light isn't just a speed limit for objects. It's also a speed limit for causality. It determines the structure of space-time itself. It determines what can possibly influence what. Now, I want to be careful here. The universe is quantum mechanical at small scales, and there are some subtleties in quantum mechanics about how causality works. But even in quantum mechanics, nothing goes faster than light. Information cannot be transmitted faster than light. The light cone structure is still there, still fundamental. It's still the structure that determines what can be connected causally. So here's my main point, and I want to be very clear about this. When Einstein said that the speed of light is special, what he was really saying is that causality has a speed limit. The universe is not instantaneously connected. It's connected through a web of causal influences that can only propagate at the speed of light or slower. And once you understand that, relativity becomes less about bizarre effects like time dilation and length contraction, though those are real, and more about something fundamental, the structure of causality itself. The speed of light is the speed of causality. That's what it's really about. Light just happens to travel at that speed. But gravitational waves travel at that speed. Electromagnetic waves travel at that speed. and the ultimate speed of any cause affecting any effect is that speed. Understanding this completely changes how you think about space and time. You stop thinking of them as a backdrop where things happen. You start thinking of them as fundamental aspects of how causality is structured in the universe. And that fundamentally is what relativity is telling us.